Alright, so it's our last lesson, Precalculus. So we're going to be looking at limits again, but instead of looking at graphs or at tables, we're going to be looking at them analytically, which just means solving for them algebraically versus having a graph. So we're doing the exact same thing we were doing yesterday. It's just if you don't have a graph in front of you, or if you don't know what the graph looks like, you can take this approach, okay? So, some rules here. We're going to be just looking at the first part first. So for limits, it's x approaches c. So when they give you some number, okay, as x approaching, you're always going to try direct substitution first, which means we're just going to plug in the number and see if it works. If it doesn't work, when I say it doesn't work, maybe you end up with a 0 in the denominator, and you can't have that. You're going to either simplify or factor to rewrite the function. Okay, so if it doesn't work direct substitution, then we're going to simplify or factor. And then another option we have is to rationalize. Okay, so when we get to it in a little bit, we'll be doing this as x approaches infinity. So guys, when we get to as x approaches infinity, we're thinking about our end behaviors that we've talked about previously. So we'll take a look at that in a little bit. So, first example, we have the limit as x approaches 2 of 3x squared minus x plus 2 and over x plus 2. Okay, so the first thing, look at your limit. If it says the limit as x approaches some number here, okay, if it says a number, what you're going to try to do first is direct substitution. That literally means just take that 2 and plug it in everywhere there's an x. Okay, so your first step is to try direct substitution, plug in 2. So we'll have 12 minus 2 plus 2, so just 12 on top here over 4. So we end up with 3. As long as this is a real number and it works, well, that is the answer to your limit. Okay? That's all you had to do. Now, it doesn't say if it's from the left or right here, so it doesn't matter if they would have put left or right there, you would do the same technique. What this means is this graph is continuous, so from the left and the right would be approaching that y value of 3. Okay? So we take a look at the second one. The limit as x approaches 64 of the cube root of x. So it's the limit as x approaches a number, which the number is 64. So we're going to try to do direct substitution first. So the cube root of 64, which is 4, which is a real number. So that would be the answer for your limit there. Okay? So that's what you always try first. Even if some of these look super complicated, always try to plug in the number first, which is called direct substitution. If it works, then you're finished. So next we're going to take a look at number 3. So for number 3, we have the limit as x approaches 2 of x cubed minus 8 over x minus 2. Okay, we have as x approaches 2, so since we have a number, we're going to try to do direct substitution first. So plug in your 2 everywhere there's an x. Well, we're going to have 8 minus 8 on top, which will be 0, over 2 minus 2, which is 0. You cannot have 0 in the denominator, okay? So, the answer is not 0. The answer is does not exist. You just have to do a different process. So what you're going to do, if you get 0 in the denominator, okay, that means it doesn't work. Then the second step said we're either going to simplify or factor. Well, if you look at this, we could factor it. So we're going to factor before we actually take the limit. So these are perfect cubes. So guys, if you remember, perfect cubes have this form AB, A squared, AB, and then always plus B squared. Because we're working with subtraction, the subtraction goes first and the addition second. Okay? A is the cube root of that x cubed, so A is going to be x here. And B is going to be the cube root of that 8, which is going to be 2. So to factor that numerator, we're going to have x minus 2 times x squared plus 2x plus 2 squared, which is 4. And then in the denominator, we're going to just have x minus 2. It can't be factored. Well, what happens there? Now, you can cancel out these x minus 2's. So all we're left with is this x squared plus 2x plus 4. Okay, so once again, we tried to do direct substitution. We had 0 in the denominator, so we had to come up with a different way to do this. So we factored. Okay, we factored, there's a reason that you factor, so these two things will cancel out. We're just left with this. So now we're ready to find the limit as x approaches 2. So once you've gotten to this part, you get to do direct substitution again. You're just going to plug in that 2 everywhere there's an x, and hopefully it'll work this time. So we're just going to have 4 plus 4 plus 4, so we end up getting an answer of 12. The answer to that limit would be 12 there. Okay, so then taking a look at number 4. So the limit as x approaches 1, 2x squared minus 5x plus 3 over x squared minus 1. So x approaches 1, so we're always going to try to do direct substitution first. It really doesn't matter what the numerator gives you, but if you see the denominator is going to be 0, then you can't do that. Okay, it doesn't matter about the numerator. Alright, so we're going to try to factor this and see if it will help us maybe cancel something out where we won't have a 0 in the denominator. So just a reminder on factoring, we're going to have to use the AC method here because we have this 2 out front. So 2 times 3 is 6. Two numbers that multiply to 6 and give us negative 5. We're going to have 6 and negative 1. Sorry. Brain fart here. We have negative 3 and negative 2. So we're going to bring down our first term, 2x squared minus 3x minus 2x. Bring down your fourth term, plus 3. Grouping. GCF here is x. We'll have 2x minus 3 left. GCF here, we'll just take out a negative 1, and we'll have 2x minus 3. So we end up with factored as x minus 1 and 2x minus 3. Okay, so my numerator is x minus 1, 2x minus 3. Over, now factor in the denominator here, so you do perfect squares, so we can make it x plus 1 and x minus 1. Take the square root of each part. So that means x minus 1 is going to cancel, so we are just left with 2x minus 3 in the numerator over x plus 1. So our factoring got us able to cancel one of our factors, which was the purpose. So now we're going to bring down our limit as x approaches 1. It's the limit as x approaches a number, which is 1, so we're going to do direct substitution and plug it in. So we're going to end up with negative 1/2, and that will be our answer. So you're going to always do direct substitution first. If it doesn't work, see if you can factor the numerator and denominator one or the other. When you factor, something should cancel out, and then you should try to do direct substitution. Okay? So let's take a look at number 5. Okay, so we have the limit as x approaches 3 of the square root of x plus 1 minus 2 over x minus 3. Now, we're going to do x approaches 3, so we're going to plug in 3. Always try that first. Well, you don't have to worry about the numerator. The denominator is going to give us 0, so we can't do that. So the first step says to factor, or the second step technically says to factor, but you can't factor with the square root here. So we're going to do something called rationalize. So what this is going to look like, you're going to take your whole fraction that you have here, and you're going to multiply it by what's called the conjugate of the numerator. So you're going to do the exact same thing as the numerator, but you're going to change this minus to a plus. And if you put it in the numerator, you have to put it in the denominator as well, because that's like you're multiplying by 1. Okay? So we are going to only multiply out the numerator. So if I multiply out the numerator here, the square root of x plus 1 times the square root of x plus 1 will make those square roots cancel and just be x plus 1. Okay? Because these are conjugates, you don't have to do the middle term, but I'll show you what happens. So if we multiply this times positive 2, we'll have plus 2 square root of x plus 1. If we multiply times this negative 2, we'll have negative 2 square root of x plus 1. And then negative 2 times 2 will give us negative 4. Well, the reason I said you don't have to do the middle terms is because, look, these two things cancel out here. Okay? For the denominator, do not multiply it out. Just write it as 2 separate factors. Like that. So let's clean it up. In the numerator here, I have the x, and then I have 1 minus 4, so that's really negative 3. And then remember, you're not going to do anything in the denominator, just write your factors. Well, hopefully you see something in here. Now my x minus 3's can cancel. So we left nothing in the numerator, so we have to put the placeholder of 1. And in the denominator, we're left with the square root of x plus 1 plus 2. Okay, so we're going to bring down our limit as x approaches 3. And now, because we had the limit as x approaches number, we're going to do direct substitution and plug in that 3. So we're going to get 1 over the square root of 4 plus 2, so 1 over 4. So 1/4 will be our answer for that part. Okay? So you're going to try direct substitution. It doesn't work, you're going to think about factoring. If it's something crazy like a square root, you can't factor, so you're going to rationalize. And then you should be able to do direct substitution because a factor should have canceled, which will make that 0 in the denominator go away.